Counting problems for the ACT. Question 1. In how many different orders can 4 distinct books be arranged on a shelf? Here's step 1, the question we always ask for a counting problem. Does the order of the objects matter? This question tells us yes. So this is a permutation question. Combination questions don't care what the order of the 4 books would be. But this is a permutation question, so the answer is just 4 factorial because we do 4 times 3 times 2 times 1. That's 24. So the answer is D. Now that's answer choice D in the free Permutations and Combinations study guide at classictestprep.com. Thing to note, what does this really mean? Why are we doing 4 times 3 times 2 times 1? It's because we have 4 books, and if we're arranging them in order, in the first spot, we could have book A, book B, book C, or book D. We can put all 4 books in that first spot. If we move on to the next spot, we have to leave a book in the first spot, right? So there are only 3 other books to choose from. And so we choose one of those books in spot 2, and then we only have 2 books left for the third spot. And then we have to leave a book in the third spot. So there's only 1 remaining option for the 4th spot. And that gives us the number of different permutations, the number of different ways we could organize these 4 books. All right, let's talk about question 2. A teacher picks a 3-student committee from 8 students. How many committees are possible? Now, this is not a permutation question. This is a combination question because we don't care which seat the student occupies on the committee, right? We don't care about the order. We just care about which students are on the committee. So we have 8 students to choose from for the first spot in the committee, 7 students to choose from for the second spot in the committee, and 6 students to choose from for the final spot in the committee. Times 7 times 6. And right now you're thinking, this looks exactly like the previous example question. So what's the difference? And we need to divide 8 times 7 times 6 by 3 factorial because we're filling out 3 spots. So we have 8 times 7 times 6 over 3 times 2 times 1, which simplifies to 336 over 6, and that is 56, answer choice C. So the trap for this question is that 336 would be the amount of possible permutations for this committee, but we just need the combinations, right? Order does not matter, so we have to divide by 3 factorial and get answer choice 56. All right, question 3. From 4 women and 5 men, form a committee of exactly 2 women and 1 man. It's still a committee, so order does not matter. So we're working with combinations here, but there are 2 categories, so it's a little bit weirder than the last example. Choose 2 of the 4 women. So that's 4 times 3, because there are 2 spots. But then we have to divide by 2 factorial. So we have 4 times 3 over 2 times 1. So that's 6. And now we have to choose 1 of the 5 men. There are 5 men and only 1 spot, so it's actually just 5 over 1. And so now we have to multiply 6 times 5 to get 30, which is answer choice B. The trap here would be to add these options instead of multiplying. Final one, 8 runners race for gold, silver, and bronze. How many ways can the medals be awarded? Now, think about this question. Does the order matter here? It's very similar to our 8 students for 3 committee roles question earlier, But the order actually does matter because gold, silver, and bronze are all different. So we care about the order. This is a permutations question. And now we're just picking 3 spots out of the 8. And so we have to do 8 times 7 times 6, which is 336. And that's answer choice A. So if you had chosen a combination here instead of a permutation, right? So if you forgot that the order matters for this question, you'd get 56, just like answer choice or question 2. So we need to remember that the first thing we have to identify is, does the order matter or not?